Hello friends, welcome to Achur Academy. In the last lecture we have completed our discussion on the problem number 7. So in this particular lecture we will discuss question number 8 onwards. So let's begin. So this is lecture number 56 on the fluid dynamics module. So let's start our discussion. So what is given in the question is that with a rigid boundary in the form of a circle. So the expression for the circle is given. And there is a liquid motion due to a doublet of a strength mu at a point 0, 3 alpha. Okay, so at 0, 3 alpha there is a doublet, okay, with its axis along the axis of y. So the axis of the doublet at this point 0, 3 alpha will be along the y axis. Okay, so what we have to show that the velocity potential is given by this expression. Okay, so this is very simple question, provided you have the concept of doublet. Okay, so that we have already studied. Okay, so let us draw the circle. We have the circle with the center as, okay, so the center of circle is, this is our expression for the circle. So the center will be minus alpha comma 4 alpha, okay, or radius will be 8 alpha square root. This is 2 root 2 alpha. Okay, so let us write down the, so the radius of this circle will be minus alpha comma 4 alpha. Okay, so this will be our axis. So this is at the x coordinate of this is at a distance of x alpha from the x axis. So let this with the y axis, sorry, this will be at a distance of alpha from y axis. So this is our origin. Okay, so this is at a distance of alpha from here. So this distance is alpha and this distance is 4 alpha. Okay, so we have the doublet of strength mu at a point 0, 3 alpha. Okay, so the point will be around somewhere here. So first we have to calculate this point for deciding the position of this 0, 3 alpha. What we have to do, we have to calculate these 2 points, the coordinates of these 2 points. So at these 2 points, this is on y axis, so x component will be 0. So we have the equation of circle as x plus alpha square plus y minus 4 alpha square is equal to 8 alpha square. So let us put x is equal to 0. So we have alpha square plus y minus 4 alpha square is equal to 8 alpha square. So this will be y minus 4 alpha is equal to 7 alpha square. So this is under root. So this is y minus 4 alpha is equal to root under 7 alpha plus minus. So we have y1 is equal to 4 alpha plus root under 7 alpha, or y2 is equal to 4 alpha minus root under 7 alpha. So the value of root 7 is 2.64. So this is 4 alpha minus 2.64 alpha. So this will be 1.36 alpha y2. So this coordinate will be 1.36 alpha. Okay, so this is 0, 1.36 alpha. Okay, this will be 2.64 plus 4, so 6.64 alpha. 0, 6.64 alpha. Okay, so this we have 1.36 alpha. Okay, this is 6.64 alpha. Okay, so our doublet is at a point of 0, 3 alpha. So 0, 3 alpha will be somewhere here. 0, 3 alpha. So this is the position of doublet. So let us consider this point as P. Okay, so this is at a distance of alpha from here. Okay, and this distance is 3 alpha. Okay, so the image of this point will lie outside this circle. So let this point be P dash. We are not sure about P dash, whether it is on x axis or not. So let us consider this somewhere here, P dash. Okay, so this distance, so we have to calculate this OP dash. Okay, so this is OP and this is OP, this is OP dash, this is OP. So since P dash is the inverse point of P, so we have OP into OP dash is equal to radius ka square. So radius is 8 alpha square, so this is 8 alpha square. So the value of OP will be, so let us calculate this distance. This distance will be alpha square plus 4 alpha minus 3 alpha. So alpha square ka root, this is root 2 alpha. Okay, so this distance is root 2 alpha. So root 2 alpha into OP dash is equal to 2 into 4 alpha square. This is alpha gets cancelled. So this is OP dash is equal to 4 root 2 alpha. Okay, so this whole distance is 4 root 2 alpha. Okay, 4 root 2 alpha, this whole distance. So this distance will be, this is root 2 alpha, this is 3 root 2 alpha. Okay, this distance. So OP dash is equal to, so PP dash is equal to 4 root 2 alpha minus root 2 alpha, this is 3 root 2 alpha. Okay, so this is 3 root 2. So we have circle like this. So this is P dash and this is 3 root 2 alpha and this is 3 alpha. Okay, so let us calculate this angle. So what is this angle? So we have this as this like this. So we have to calculate this angle. So let us consider this as theta. And this is 3 alpha, this is 4 alpha. So this will be alpha and this distance is alpha. So this will be 45 degree. So this will also be 45 degree. So this is pre alpha. And let us calculate this with using this 45 degree. So this angle will be, suppose this point is P dash is on the x axis, then we have this distance as 3 root 2 alpha using this angle 45 degree. So this means that P dash, the P dash point, that is the inverse point of P, is lying on the x axis. So okay, so this point will be on the x axis. So we have assumed this outside above this x axis. So this means, and whatever calculations we are getting with respect to this 45 degree, then this is lying on the x axis. So this P dash is on x axis. Okay, so the coordinate of this will be 0 comma, this will be 3 alpha comma 0, and coordinate of P is 0 comma 3 alpha. So here the doublet is of strength mu. So what will be the strength of doublet at P dash? The strength of doublet mu at P dash, mu dash, is equal to mu into radius square upon, since we are calculating this, so we will take this distance OP, the OP square. So this is equal to mu into 8 alpha square upon OP. So OP is root 2, the 2 alpha square. So this is 4 mu. Okay, so this is 4 mu. Okay, so we are having a doublet at P and doublet at P dash, that is image of this, and P dash का क्या है? P dash का जो strength है is 4 mu. So let us write down the equation of the complex potential. Okay, so we have the complex potential as so we have like this. So we have this is P dash and this is P. The coordinate of P is 0 comma 3 alpha. Okay, and this is 3 alpha comma 0. So let us consider this point as Z1 and this is Z2. So Z1 is equal to 3 alpha I and Z2 is equal to 3 alpha plus 0 I. Okay, so now and the strength of doublet is mu, and here the strength of doublet is mu dash is equal to 4 mu. Okay, so let us write down the equation of complex potential. So W is equal to mu, and since this is in direction of y axis, the mu e to the power I pi by 2, since it is in direction of y axis, and z minus z1 plus mu dash into E. So this is on the x-axis, so the direction of this will be along the x-axis. So I into 0 upon z minus z2. So now let us put the value. So this is mu into ei to the power 5. So this is cos pi by 2 plus I sin pi by 2 is equal to I. So this is I upon z minus z1. So z1 is 3 alpha I plus mu dash is equal to 4 mu upon z minus z2 is 3 alpha. Okay, so we have, let us further simplify this. W is equal to 3 alpha I plus 4 mu upon x minus 3 alpha plus I into y. Okay, so let us x plus y minus 3 alpha, and this is after putting z is equal to x plus iy. Okay, so this is x minus 3 alpha plus iy. Okay, so let us divide with its conjugate. So we have w is equal to mu I x minus y minus 3 alpha into I upon x plus y into 3 alpha into I into x minus y minus 3 alpha into I. Okay, plus 4 mu into x minus 3 alpha minus iy upon x minus 3 alpha plus iy into x minus 3. So this will be mu I into x minus y minus 3 alpha into I upon x square plus, this is a square plus b square. So I square will be minus 1. So minus minus plus. So this is y minus 3 alpha ka whole square. Okay, plus 4 mu into x minus 3 alpha minus iy x minus 3 alpha ka whole square plus y square. This is 5 plus I psi. Okay, so what we are being asked is velocity potential. So velocity potential will be the real part. So phi is equal to, let us find out the real part. So mu I into y minus 3 alpha into I. So this will be I square will be plus. So mu into y minus 3 alpha. Okay, let us take mu common. Okay, upon x square plus y minus 3 alpha whole square plus, this will be from here, this is 4 mu x minus 3 alpha, and this is imaginary part, so we will take, and mu is outside, so this is 4 into x minus 3 alpha upon x minus 3 alpha whole square plus y square. Okay, so let us check this. So this is our velocity potential. So y minus 3 alpha upon x square plus y minus 3 alpha. So this term is there. Okay, and 4 into x minus 3 alpha upon x minus 3 alpha whole square plus y square. So this is this term. Okay, so we have calculated the velocity potential. Okay, so total 8 questions we have discussed on this topic. Okay, so in this next lecture we will discuss another topic. Okay, so thank you.